Okay, we're going to deal with the hideously complicated looking graphs now. I'll just try and get the focus right. Yeah, that's better. Yeah. So, they do look horrendously complicated. They're not as difficult as they look. So, this is the menstrual cycle. So along the bottom we've got 0 days through to day 28, assuming that 28 day cycle. I mean, it's not the same for everybody. So we've got the events, and sort of our events from the top to the bottom is what's happening in the ovary, what's happening to body temperature, the levels of hormone in circulation that are being released from the anterior pituitary, remembering that they have to go all the way through the circulation. So they're going back in through the vena cava, through all the chambers of the heart, back out through the aorta, and down to the ovary and uterus, where they're somewhere down to the ovary really, where they're having their effect. And then you've got the ovarian hormones released from the cells of the ovary. And of course they're going, trundling all the way through the circulation from the ovary, and then having their effect on the uterus. So I think we'll just take it we'll start at the beginning of the cycle, why not? So at the beginning of the cycle, the first day of the period is day 0, and this is when the previous month's endometrium is being shed. Now, the reason that it's being shed is at the end of the last cycle that there was no fertilisation and the corpus luteum's degenerated and stopped churning out estrogen and progesterone, which have been maintaining the lining of the uterus. So the uterus lining is then shed at menstruation. What's happening elsewhere in the body then is that usually, in a sort of a negative feedback way, estrogen and progesterone inhibit the anterior pituitary hormone, follicle stimulating hormone, so that you don't get continuous release of FSH. So the FSH levels, I'd have put this bump a little bit earlier to be honest, starts to be released during menstruation, and it's that is then triggering. FSH stands for follicle stimulating hormone, so it's triggering the development of this follicle and the proliferation of these granulosa cells. So during menstruation, what's happening? Estrogen and estrogen and progesterone levels are low. That enables, it removes the inhibitory effect from the anterior pituitary, so you get FSH, green one, released, which stimulates the follicle to start developing. Now you can see that the follicle cells are quite proliferated by the time we get to day 5, 6, again, quite variable. And those cells are now churning out estrogen. And the estrogen is building the lining of the uterus up, so ready for an ovulation and a potential pregnancy. It's going to be all lovely for the blastocyst to implant into. So estrogen builds up, inhibits FSH, so the FSH levels dip in this stage, and then there's a kind of a positive feedback effect at this peak of estrogen here, causing a release of 2 anterior pituitary hormones. We get this little spike of FSH and a bigger spike of luteinizing hormone. The luteinizing hormone is in charge, and this sort of double peak here is in charge of causing ovulation. So this is when the follicle bursts open and releases that secondary oocyte into the fallopian tube. You can see on the temperature graph it's accompanied by a bit of a spike of temperature, and I think that's how those sort of red-green, this is your fertile time machines that you can get in the chemist's work, because they monitor your temperature, and when it spikes, then obviously you've just ovulated, the secondary oocytes in the fallopian tube, that's a really good time to get pregnant. The corpus luteum then forms in the ovary, and that churns out estrogen and progesterone, and just like before, estrogen and progesterone inhibit, in a negative feedback way, the release of LH and FSH. They also have an effect on the uterus, and they maintain, building and maintaining that endometrial lining, so that it's in a really good state for if a fertilisation happens. At the end then, those levels drop as the corpus albicans forms, and as soon as they get low, don't maintain the lining, and the FSH can be released again. So you're ending again with menstruation here. So that's sort of, the graph's that long, so that bit there is the same as this bit over here, that bit there is the same as this bit over here, that bit there, over here, etc. And you can see that the temperature drops down a bit towards the end. So, well, that's it really. It's not as complicated as it looks. However, if I was you trying to learn this, I would now put those hormones onto a table with where they're released from and what they do, and concentrating on that sort of negative feedback aspect. Remembering negative feedback is inhibiting, it's preventing that change. So, there are a couple of other hormones that you need to be aware of. So, this is the graph for if a pregnancy doesn't happen. But of course, if a pregnancy does happen, this corpus luteum is going to be maintained by the release of human chorionic gonadotrophin from the chorionic villi of the developing embryo. That sort of goes on about 12-16 weeks or so, and then the placenta is going to take over and secrete out the progesterone and the estrogen, which are going to then inhibit the FSH and LH, just so that you don't get more of these sort of growing follicles and more and sort of successive pregnancies happening in the same place. The estrogen also helps the uterus to grow and develop to accommodate the fetus as it gets bigger. It stimulates the growth of mammary glands and the formation of milk-producing tissue. And progesterone actually stops the uterine wall contracting. So again, just before birth, the estrogen levels increase and the progesterone levels go down. That means that because you've lost the progesterone, the uterine wall can now contract in response to another hormone called oxytocin. Oxytocin is a posterior pituitary gland hormone, just like ADH is, and it stimulates the contraction of the uterine wall. Again, this is a positive feedback mechanism. It's one of the few available to you. Effectively, you start reducing oxytocin, the uterine contractions start. The more contractions you get, the more oxytocin you release. So you're increasing that effect, and so the contractions, and trust me on this one, get bigger and stronger as birth progresses. We've also got one more hormone that you need to know, and that's prolactin. This is an anterior pituitary hormone, and that's in charge of production of milk by the mammary glands. Again, oxytocin has a releasing, contracting kind of effect. So while a baby's feeding, it's kind of stimulating the nipple. The prolactin's in charge of milk production. There was plenty there. And then the oxytocin actually sort of squeezes on the milk ducts and forces the milk out. The babies aren't sucking milk out. It's kind of being forced into their waiting mouths. Again, quite interesting. So, you need to know all of those hormones. You need to know their site of release, and you need to know what it is they do, and particularly if they've got a role in negative or positive feedback. So, by far the best thing to do is to make yourself a table with that information on it. So enjoy doing that.